Good. So yesterday we have covered the NAT concept, if you guys remember that. So basically, first we have seen the concept of VRRP protocol. So VRRP is a IEEE standard protocol if you compare with HSRP, right? So if you have a multiple vendor of the devices in your network, then you have to go with the VRRP. If you have a Cisco, then of course go with the Cisco, right? Then after that, we have seen the concept of the NAT. So NAT was originally introduced in the 1994, and but in 2000 the widely people are using the NAT protocols. NAT is not a protocol, so NAT is a feature. So we have a static NAT, if you guys remember that. Then we have seen the dynamic NAT concept, right? And then we went for the PAT. So this things yesterday we have covered. So or it's not, it doesn't mean that like a static NAT is a one-to-one NAT. We are not using this thing. It depend on the scenario. All the NAT are being used in the production network. You cannot say the static NAT is a bad and dynamic NAT is a good or PAT is amazing. All these three NATs are used by the production network right now. It's totally depend on the scenario by scenario. Now, with scenario, you will understand this part when you're going to learn about the CISA enterprise or when you're going to learn about the CISA security, then you will go through the much detail about this thing, right? Now, in the NAT, basically what we have covered that we have seen the basically RFC 1918 address, right? So in the RFC 1918 address, what happened? We have a private IP addresses, right? And we have a public IP addresses as well. So the major difference is that we have seen this thing, right? So major difference is that what private address is not a routable address, right? So basically what happened, your ISP will not route this address. Right? So that's the meaning of routable. So ISP will not route this address. That's why it's a private address is not routable address. You can use this address within the company network, but you cannot go beyond the company. Whereas if I talk about the public address, it's a routable address. So ISP can route this address, right? Even you have to pay the money for the public IP address, but the private IP address is free to use it. It's a totally free, you can use it. So for example, understand this concept. So we have a PC1 over there, right? And we have another PCs over there, and there's a switch in between, right? So switch provide the connectivity between the PC, right? Then we have a routers over there, and then we have another routers, and then we have ISPs over there. Understand the concept right now. So within the network right now, understand this is my internal network, right? This is all my internal network we have. So we can use the any private IP addresses. I can use the 192.168.1.0 subnet in this LAN network. Over there, I'm going to use the 192.168.2.0 network, right? But between the ISPs, between the ISP and customer router, I'm going to use the public network. I can use the 1.0.0/8 network. So within the company organization, you can use the private IP address. It's free to use, or it can be duplicate because some other company also you're going to use the same address as well, right? But on the WAN side, always I'm going to use the public address. So that's why the NAT comes in the picture. Now, again, right, NAT is an amazing thing. Okay, take example, same thing. I have some site over there. Take example, we have a router 1, right? And then we have a ISP in between. Okay, and then after that, let me bring this guy, and then we have another router again. So assume that there is a router 1 and router 2, and this router 1 and router 2 has a connectivity with the ISP, right? So router 1 has a connectivity with the router 2 through the ISP. So this is my router 1. Guys, please pay attention. It's a very important topic. Router 2, and we have ISP, service provider. Of course, right, between this guy to this guy, I'm going to use the public IP addresses. The reason is that it's the WAN connectivity. So this is my 0/0 interface, right? This is also my 0/0 interface. This is my 0/1 interface, right? And this is my 0/1 interface as well, right? And here we have a public IP addresses. I can call as a 101.101. And this is the subnet I have, 1.0.0/8 over there. Same thing, I have 1.1.2 over there. Right? So these are the public IP addresses we have between the customer and service provider. Same thing, we have IP addresses over there. It's 2.2.2.2.2. And the subnet I have over there, it's a 2.0.0/8. So these are my, again, public IP addresses and 2.2.2.1 over there. Now, apart from this thing, I have some users that are connected in the LAN network. So you can say that, okay, this is the switch I have, right? And this switch has a connectivity with the router right now. Okay. And I have a few users that's part of the VLAN number 10, or I have another user that's part of the VLAN number 20. Okay. I'm going to make a very easy right now, guys. Please pay attention. So this is the part of the VLAN number 10. At the same way, I'll take the another diagram, another color. So this is for the VLAN number 20 right now. Okay. Copy and paste. So we have a connectivity. Let me this right. Same thing, we have a switch in between as well, between the different locations. So you can consider it, we have a two side. So one side in the Bangalore, another side in the Delhi, or you can consider one side in the London, another side in the India. Right. So we have a switch one, and we have a switch two as well. Right. So we have PC number one, we have PC number two. You can consider this is the VLAN number 10 we have, right? And the subnet I have a 192.0/24. Same thing, this guy has a 192.0/24. That's for the VLAN number 20. So in an India location, I have some user, right? And in a USA, United States of America, we have again two users, right? One for the VLAN number 10, another for the VLAN number 20. So this guy I'm gonna make when I use the 3.0/24. So eventually, if you see that both are using the private IP addresses, VLAN number 40, not 40. I can make this guy the 20 again. And the subnet I have of this guy could be 4.0/24. Okay, right? So what I told you that if you just have a look over there, the private IP addresses are not routable by the ISP, right? You can use in the internal network, but you cannot send the private IP address to the ISP, right? See, where the public IP address, it's a routable address. So you can see that these are my public IP addresses that's connected with the ISP, right? But the private IP address I'm using in the LAN network. Now, I want to provide the communication between this two subnet. How do I do that? So if you're going to provide the communication between this guy to this guy, what you have to do that? You just need to perform the NATing, right? So you need to go on the router number one. I need to perform the NAT on this guy. And same thing, you need to perform the NAT on this guy. And based on the NAT, now you can provide the communication, right? This is how you're going to do that, right? But the problem with the NAT is what? I'll tell you. So the first problem with the NAT is what? It introduced the delay. Delay in a simple language, you can call as a latency, right? Why it's called as a delay and latency? Why it's going to introduce the delay and latency? Understand the concept. Whenever the role of the NAT is what? It's going to do the translation. Guys, please pay attention. It's a very important topic. So NAT is going to do the translation. Translation is what? Converting from one to another, right? Converting from one to another. That's something of translation. So understand, so we have a source IP address will be 192.168.1.1, right? And this is the destination IP address. For example, I can call it 3.3.3.3.3, right? So what translation will do that? What NAT is going to do that? They will convert the source IP address. They will say that, okay, let me convert the source IP address with the public IP address. So this private will be converted to the public and the distance will be remain same. So during the conversion, what happened? The router will take some time and they will introduce the delay over there. First problem. Second problem is what? If I'm changing my data, understand the concept. If I'm changing my data, if you see that my data is being changed, right? My IP address is being changed right now, right? It's changing by the router number one. Same thing will happen on the router number two as well, guys. Attention. In that case, what happened? If I'm changing my data, you're losing the integrity, man. You're losing the integrity. So if I'm going to lose the integrity, my checksum will be again recalculated. My checksum will be changed over there. Okay, at the NP level, that's a very high level, these things are there. But understand the concept, NAT has a own disadvantage. Right? NAT has a own disadvantage. So that's a one problem is there in the NAT. Okay, but still we are using the NAT. The reason is that we are saving the lots of money by using the NAT, right? We are saving the lots of money. We are hiding the network from the public. So with the help of NAT, we can provide the communication. We can provide the communication. But the problem with the NAT is what only? We cannot exchange the route. Extending the router means what? Router 2, right? Router 2 cannot have this information in the routing table, and router 1 cannot have these information in the routing table. We cannot exchange the route because ISP will not allow you to exchange the route, because you cannot send these route in the ISP side. You cannot send these route on the ISP side, the private IP addresses. The private route you cannot send to the ISP. So what concept we have introduced? We say that, okay, let me do one thing. I will make one logical link. Guys, pay attention over there. So I will make a logical link. So between the router 1 to the router 3, router 2, I will make a one logical link. This logical link, right? I'm so sorry. This logical link has IP addresses. So for example, I'll say that, hey, this logical link will be IP address. I'll say the 10.1.1.1.1, right? And another side will be the 10.1.1.2. This logical link that I'm going to create between the router 1 and router 2. And through this logical link, understand the concept. Through this logical link, what I can do that, I will exchange the route. I will say that, let me share my private network. Let me share my private network through this logical link. So router 2 also will say that this private network 3.0 and 4.0. So this through this logical path, or we can say the logical link, through this logical path, we can share the routing information. How do I share that? I'm going to enable the any routing protocol, right, on this logical link. And once I'm going to enable the routing protocol, right, they will form the neighborship, maybe the OSPF, maybe the EIGRP, maybe the BGP, maybe the static routing, anything, any routing I'm going to enable on this logical link, right? Because I have an IP address on this logical link, 10.1.1 and 10.1.2. Once I'm going to enable the any protocol on this guy, they will form the neighborship, right? They will form the neighborship, and after that, they can exchange the route. Beauty part. Beauty part is what? In that case, I don't need to perform the NAT on the route. I can save the lots of memory. I can save the lots of CPU. No need to have a delay. I don't need to perform the NAT. And now, eventually, what happened? This guy can communicate with this person. And router 2 can maintain the 1.0 and 2.0 information, which is from the India side. So USA will have a United States of America have a 1.0 and 2.0 information. And the India has the information about the 3.0 and 4.0 in the routing table. This logical network that I'm going to create, right? This logical network that I'm going to create, which is known as a VPN, virtual private network. Now, what people are thinking about the VPN? What the myth is there about the VPN? The myth about the VPN is what? Security. No. There is no security. VPN, what VPN is doing, like, understand the concept. What VPN is doing that? VPN is just providing the connectivity, right? VPN is just providing the connectivity between the two or more sites. That's all. It never provides the security, never. It just providing the connectivity. Can you see that? We have one side in the India location, another side we have in the United States, right? I'm just providing the connectivity between this two sides. And this, through this logical link, I'm going to exchange the route. That's called as a VPN. VPN means what? VPN doesn't mean the security. VPN only going to provide the connectivity. And the foundation of the VPN is what? The foundation of the VPN is called as a GRE, generic routing encapsulation. The foundation of the VPN is known as a GRE. So any person who is gonna start the career in the VPN part, they have to first learn about the GRE. So the meaning of VPN is what? Virtual private network. Why is the virtual? The meaning of virtual means what? So we have a logical link over there. Can you see that this is the logical link we have over there? So that's the meaning of virtual. Why I'm saying the private? Because these are my this link is gonna carry my private network over there. So it will create the own infrastructure. So already I have a one physical infrastructure. Guys, attention. Already I have a one physical infrastructure. Over the physical infrastructure, I'm creating the one logical infrastructure. That's the meaning of VPN. So VPN, what allow the VPN? It allow the connectivity between two or more sites. So either you can connect the two side, either you can connect the more side as well. So I just have a two side right now. You can connect the more side. So take example, if you have a Dubai branch, take example, we have router 3 as well, right? And router 3 also have some VLAN number 10 and VLAN number 20, right? You can also connect the Dubai branch as well. So that's like the two or more side over the public network. So that's the meaning of VPN. VPN is what? It's just going to provide the connectivity between the two or more sites over the public network. So you can see that. So connectivity between the two sites, router 1 and router 2, USA and India, over the public network. And that's going to create the another infrastructure that's called the overlay network. So this is my underlay network. Understand, guys? This is my underlay network. Right? And underlay means what? You can say that hardware network, right? Because we have a connectivity through the physical media, right? We have a connectivity through the physical media like a 0/0 and ISP we have. Over this underlay network, what happened? I'm creating the another network, a separate infrastructure. That's my logical network. And this logical network is known as a overlay network. This logical network is known as a overlay network. I know this terminology is hard, but guys, don't worry. You will understand this thing once you go in the deeper side. So many person has a confusion. Okay, what is the underlay? What is the overlay? So when you like go in the LinkedIn and check, the many person, right? People are putting the overlay and an underlay concept. Like a SD-WAN is the underlay. I'll tell you what. When the SD-WAN comes in the market near around 2017 and 18, right? That time this overlay terminology was in the very in the buzz, right? So people are saying, okay, SD-WAN is the overlay technology. No, the term overlay, it came in the 1995 only, 1994 only. But people has no idea about this thing, like what is overlay and what is underlay. Overlay means what? A logical network. If you're creating a separate infrastructure over the underlay network, that's called as the overlay logic overlay infrastructure or overlay network as well. So right now, how the overlay will look like this. So now that we have router 1 and router 2. So once I'm going to create the logical link between the router 1 and router 2, so your overlay network will look like this now. So you will know how a ISP in between. So now the network between this guy is what? So this IP of the router 1 link is a 10.1.1.1. And this is the 10.0.0.0/8. And this is the 10.1.1.2. So this is my logical link we have. And this router 1 has a 2 network. So I'm not going to write the user's name. I'm just going to write the VLAN 10. This guy's a 1.0/24. Right? Same way, we have a VLAN 10 and 20 over this guy as well. But this guy has a 3.0/24. So now what I can do that over the overlay network that's we have over this, I'm going to run the any routing protocol, maybe EIGRP. So through the EIGRP, what happened? I'm going to exchange the route. So ISP will be never comes in the picture, right? So the route will be exchanged through the overlay network. This is called what? This is called our GRA, generic routing encapsulation. So the meaning of encapsulation, the meaning of this what do you meaning of encapsulation of GRE? You will understand when I'm going to do the practical. But this is called as the foundation of the VPN. GRE is called as the foundation of the VPN. All good, guys. So this logical network that you can see that over there right now is created by the underlay network. So if your underlay, take example, if your underlay goes down, It means that if there is an issue in the link connectivity between the this guy to this guy, or maybe this guy to this guy, if you have any issue with the underlay, you're automatically overlay going down. So overlay network is totally depend on the underlay network. It's totally have a dependency on the underlay. If your underlay is working fine, you have an overlay. So whenever the troubleshoot comes in the picture, remember always one thing: whenever any troubleshoot, anywhere in the production network, either you are doing the SD-WAN, either you are doing the SDXS, either you are doing the ACI segment routing, like a GRE, VPN, any part, MPLS ever, check the underlay connectivity. If your underlay is working fine, right, then troubleshoot the overlay. But if your underlay has some issue, don't troubleshoot the overlay. All good? So let's do the practical how you can achieve this. It's a very simple one. VPN doesn't mean that it provides the security. VPN just provides the connectivity. So the people are using the VPN in the laptop and what we call in the mobile phone and saying, okay, I'm getting the security. You are not getting the security, man. You are just they are just helping you to provide the connectivity from your phone to the another site. That's all. GRE, I think so. This one. So GRE is a foundation of the VPN. So GRE works on the layer 3. It has a protocol number is a 47. So GRE is a layer 3 encapsulation mechanism. GRE is not a protocol. GRE is a encapsulation mechanism, works on network layer. Right? The protocol number of this guy is a 47. It provides the point-to-point connectivity. So let's have a look over there. You can see that this is the same network I have drawn over there in the paint file as well. So we have 1.0/878 between the router 1 and router 2. You can see that, right? And between the router 2 and router 3, you can see that it's a 2.0/8 subnet. I have you can see that the tunnel I'm using. So this is the logical link I have. So this logical link has a network is 12.0. And the IP address of this interface, I'm going to use the 12.1. The IP address of this interface, the logical link that I have, I'm going to use the 12.2. So this is the one branch in the Cisco Delhi, another branch in the Cisco Kabul, right? And I have a few VLANs over there, 1.0/24 and 10.0/24. Same thing, 2.0 and 2.0/24. So I just need to have an underlay connectivity, right? If your underlay is good, your overlay will be fine. So what I can do that, I'll just see the whatever the connectivity I have. Let me write on all the configuration in the notepad so that you can do this lab. So IP address will be 101. So. Okay. If you go with the GRE Wikipedia, right? So GRE was a Cisco one. Okay, it was introduced by the Cisco. It is not a IEEE standard, right? It was a Cisco one. Let's go with the Wikipedia. So it was introduced by the Cisco system. It just provides some network layer protocols. It's a point-to-point links, right? Right. And if you see, the protocol number is 47. That's already discussed, right? And what I want to show you that history, go with the history they have. They were introduced in the 90s time. It's not a new thing. First of all, I'll tell you, it was introduced in the nearby 90s. So this is the first RFC I have, 1994. So before the 1994, this features comes in the market, right? So it's not a new. But yeah, if I talk about the interview perspective, 100% you will get the question from me. The VPN is always evergreen part. All done. So this is the /8 submit, no shutdown. On the router one, if you see that I have a loopbacks as well. So that's I'm going to consider. So description, I'll put it this guy. I'll consider this guy as a VLAN number 10. Right? As the IP address will be 101/24. No need to put the no shutdown. Interface loopback number 2. Description, I say that. VLAN number 20. IP address will be 10.1.1/24. This is the classmates we have. On router 2, if you see that, I just have a, ISP, right? Interface 0/0. I have a 1.1.2 right now. /8 over there, no shutdown. Interface 0/1. IP address will be 2.2.2.1/8 over there, no shutdown. On a R3, if you see that, on R3, I just want to copy and paste this configuration, right? So this guy should be 2.2.2.2.1. Okay, this should be 2.2.2. This should be 2.2.1. Okay. And this guy should go with the 2.1. And this guy go with the 2.1 again. That's all right. So if you see the configuration on the router one, I might have configuration. Yeah, great. So I have a configuration. Let me remove the node terminal. So I'll remove the information from here as well. Okay, great. It doesn't have it. So if you see the router one, do show IP interface brief. I already have this configuration that I did on the notepad right now. Right? So this router one, someone mic is on, guys, please. So on the router one, you can see that I have IP configuration. On the router two as well, you can see that show IP interface brief. I have a proper IP over there on the router two as well. If you go to the router three also, you can see the IP address is there, right? So what you have to do that, guys, understand the concept to get the overlay network. Understand, to achieve this overlay network or to achieve the VPN, your underlay should be working fine. Underlay means what do you mean by underlay? Underlay means what? You must have a reachability from here to here. That's all, nothing else. That's called the underlay. Your underlay should be fine. If you have an underlay connectivity via anything, man, either you can do the static dot, default dot, any BGP, anything. I just need to have a reachability. If your underlay is working fine, you can achieve the overlay. But if your underlay has some issue with any routing issue, if you don't have a reachability from here to here, you cannot achieve the overlay. So to get the reachability between the underlay, what you can do that, simply gonna make a static route, a default route. So to make a reachability, router one has put the IP route 0.0.0.0.0, and as the 1.1.2, and on a R3 as well. All done. That's all right. ISP, I'm not going to do anything on the router 2 side because router is just ISP router. So I just need to provide the connectivity from my side to the ISP. That's all. So now if I'm going to ping, understand, if I'm going to ping from R3 to whom? 1.1.1. If I'm able to ping, it means that underlay is working fine. From R3, if I'm going to send the traffic to the 1.1, it means that my underlay is working fine. Now I'll do the connectivity with what? Between the Cisco Delhi to the Cisco Cloud. I just need to provide the communication between this two subnet, 1.0 to the 2.0 and 10.2.0 to the this guy. So how do I do that? I just need to create the tunnel, right? So that's a logical link. The logical link is known as a tunnel interface. You have a multiple types of logical link, guys, logical interface. One of the logical interface as a loopback interface. Another logical interface is called a VLAN interface, which is also known as a SVI. Switch virtual interface. If you guys remember that, we have seen this thing in the switching part. SVI, switch virtual interface, is also known as a VLAN interface. Okay, don't confuse with the terminology. So if you go with the higher level, you will see this terminology, VLAN interface, when you go in the data center part. Okay, this is also called as what? It's called the logical link, right? A loopback interface, also called as a logical link. Interface, tunnel interface, right? A tunnel interface is also called as a logical link. So I'm going to create the tunnel over there. I say the router 1. On a router 1, I will create the one interface as a logical link, as a interface tunnel number 1. You can create the multiple tunnel interface. If you see over there, interface tunnel, if you put the question mark, I have a bunch of range. Now, nobody will ask you how much interface, how much logical interface I can create on the router, because it's very depend on the hardware. So depend on the hardware, you will see the different range over there. So I said the interface tunnel number 1. And now I can, on this particular interface, I will give the IP address will be what? I will give the IP address will be 12.1. So this is the network that I'm going to define it. Submit mask. No need to put the no shutdown because it's already up. And now I can see that what? I'm going to create the VPN. I'm going to create the VPN from here, right, to here. So I will see the tunnel source will be what? So on the router number 1, so this interface will become the source, right? So I say the 101.1, and tunnel destination will be what? That's all. On the router number 2, at the same time, what I can do that? I'll just copy this configuration, right? And I'll paste this guy on the router number 2. I said the tunnel, same number. You can change this guy as well, right? It's a locally significant. So router 1 has a tunnel number 1, and router 3 has a tunnel number 2. Never matters. It's a locally to the router, like a weight attributes in the BGP. It's a local to the router. Same thing. It's a local to the router. And now I see the IP address will be 12.2. Same submit IP, right? And the tunnel source will be what? I can say the 2.2.2.2.2, and the tunnel destination will be 1.1.1. That's all. So let's go on the router number 1. Oh, I'm so sorry. You can see my tunnel interface is up. So I haven't put the no shutdown command over there, right? Can you see that? It's up now. So you can see that do show IP interface brief is working fine. And now, still, if you see that, I don't have a doubt. In a R3 routing table, if you see that, I don't have a doubt for the, on a R3, I don't have a doubt for the 1.0 and 10.1.0. So Kabul does not know about the Delhi. So what I can do that, on this particular tunnel interface, I'm going to run the EIGRP protocol. From the router 1, I see the router EIGRP. I'm going to advertise my tunnel network. I'm going to advertise my LAN network. I'm going to advertise my another LAN network, node or somebody. Why I'm going to put the node or somebody? Because I have a classless router over there. Router EIGRP again, 1, network, also the 12.0, network 2.0.0, and network 10.1.2.0. All done, man. So on the router 1, if you put this command, you will get the EIGRP innovation. And now you have a overlay. So you can see that I'm forming the neighborship. If you see on R3, I'm forming the EIGRP neighborship with the 12.1. So R3 is forming the neighborship with the 12.1, which is the router 1 through the tunnel interface. And now you can see the do show IP root EIGRP, but out. So I can see that on the router 3, I'm getting the 10.1.0/24 out through the tunnel interface. At the same time, R3 is getting the 1.0 route through the tunnel interface as well. Same thing if you go on the router 1, you can put the command do show IP routing EIGRP. I'm getting the route 10.2.0 through the tunnel 1. Same thing 2.0, I'm getting that through the tunnel 1. That's the amazing part of the VPN. VPN doesn't mean that security. VPN just provide the connectivity between the two sides. So now I just created this network from the underlay. And now if you want to perform the communication, I can do that, man. So if you see on a R1, I can ping which network. 1 University or 1.1, sorry, 2.1. I'm going to use the source interface is what? 1.1. So from R1, I'm going to send the traffic to the R3. From Cisco Delhi to Cisco Kabul. How the packet will go that? If you see the first pinging, I'll show you that ping is working fine. So understand the packet flow. That's a very important. So I'll put the source IP right now. Understand the diagram. So I'm pinging. So you are sitting on the router 1 right now. So I'm just draw the packet over here. Let me draw it over here. I don't have a space map. Because this part is very important. If you understand this part, then you see configuration perspective is very simple. You need to understand this part. So I have a space. I'll say the source IP will be what? I'm pinging from the 101 to the this guy. Okay. So that's source and destination. So when this packet comes to router 1, what router 1 will do that? Router 1 will look at the routing table. He said, hey, do I know about the 2.0 network? Let me check the routing table. Do so IP root. Do I know about the 2.1? According to my routing table, yeah, I know about the 2.1. This is, I'm learning through the D for EIGRP, right? And I'm learning, I need to forward the packet. If any packet is coming for the 2.0 network, I need to forward the packet to the 12.2. And this 12.2 is connected by the tunnel interface. It means that I need to forward the packet to the through the tunnel interface. So if I'm going to look for the tunnel interface right now, do show interface tunnel. Right? So he's saying that look for the tunnel interface. And when I'm going to look for the tunnel interface, do show interface tunnel, he's saying that, hey, you know one thing, whenever the any packet is coming for the this interface, that's a tunnel interface right now, what you have to do that, you need to use the tunnel source will be 1.1. Guys, attention over there. And distance will be what? 2.2. In between, what I can do that, let me add the another extra over here. Right? So I need I will add the GRE header over there, right? This header. And then I'm going to put the source will be what? It's a 1.1.1. And distance will be what? 2.2.2. Why? This is my inner header. This is my outer header. Right? So what router 1 will do, that router 1 will receive the packet. It look up the routing table. According to the routing table, he said, hey, forward the packet through the tunnel interface. When I look for the tunnel interface, he said, hey, let me do that. Let me get the another header over there. And this header will be GRE header. So now I'm going to route the packet from what? When the router will receive the packet, the router will send the packet to the router number 2. Understand, guys, ISP will receive the packet. What ISP will do that? I cannot send the packet through the tunnel interface. Reason is that because this is the logical link, man. This is the logical link. So whenever router 1 will receive the packet, it performs the encapsulation. The meaning of encapsulation means what? Remember the basic class, day 1 and day 2 of networking? Encapsulation means what? Adding something. What I'm adding over there? I'm adding the extra header. Whenever the router 2 will receive the packet, what router 2 will do that? Which header it will perform the lookup? ISP has no idea about this two guys, private network, because ISP is not going to entertain the private route. If you check the routing table of R2 right now, do I know about the 2.0 and 1.0? No, man. I have no idea about this private network. So ISP will perform the lookup for the outer network 2.2.2.2. And based on the routing table, he said, hey, I need to forward the packet to the 0/1. So ISP will forward the packet to the R3. When R3 will receive this packet, what R3 will do that? ISP R3 is going to perform the decapsulation now. Once it performs the decapsulation, it will remove this extra header and it will just send the packet to this packet to this network. So this guy is going to perform the encapsulation. This guy is going to perform the decapsulation, adding the GRE header, adding the extra header is known as the encapsulation. Removing the extra header is going to decapsulation. The customer has no idea that you have performed the user side. I'm talking the user side. They have no idea that we have performed the VPN. And even the ISP doesn't know about this thing. ISP is just going to forward the packet based on the outer header, not the inner header. So did I perform any kind of NAT over there? Nothing. We have a good-to-good communication right now. And that's how we can exchange the RFC 1918 address with the help of VPN, with the help of GRE. This is called as a VPN. That's going to provide the connectivity between the two sites. We have run the routing protocol over the tunnel interface, and through the tunnel interface, we have exchanged the route. So if you see the packet capture right now, if I'm going to forward the packet from the router one again, same one. So if you see echo request, can you see that? The source IP is 101 and distance IP 2.2.2. So he's performing the encapsulation, but out inner header, if you can see that, it's a 101 and 2.1. That's my actual packet. Same one. 101, 2.1. Then we have a GRE header. And then after that, we have a public IP addresses. So inner header, GRE, and then we have a public IP address. So GRE works on the IP protocol 47. And this is my data that I'm sending in the ICMP. So you can see that I can see my data. That's why you call it. It's not a like a secure way. It's a clear text VPN. GRE is a clear text VPN. All good, guys? Anybody has a question?
Hello.
Yep.
Uh, Side-to-side VPN meaning, sir, what?
This is called a side-to-side VPN as well. One side to the another side. It's also known as a point-to-point VPN, side-to-side VPN.
Okay, so I didn't realize that.
Point means what?
Okay, this is a
One side to
clear
the
text
other.
VPN. Always thought VPN was supposed to encrypt. Maybe
No,
I was
never,
wrong.
never,
Okay.
never. It's a wrong statement. I'll show you one thing. I'll show you the types of how many types of VPN we have. So depend on the books, depend on the things, we have multiple types of VPN. VPN, Wikipedia. The picture that I'm
IP
1 minute. So you can see that this amount of VPN you have. So majorly the VPN is what? VPN is called one is called as a customer based VPN and the service provider based VPN. Sometimes it's called a route based VPN and the policy based VPN. The VPN that we have just talked right now, the GRE based VPN, is known as a route based VPN. Also called as a customer based VPN. Why I call it a customer based VPN? Because in the GRE VPN, right, we haven't involved the ISP. So GRE is over here. Can you see that? So now you may have a question here, law, this kind of VPN I have, where I'm going to learn all those things. So depend on the, like what we call track by track. So most of the VPN, if you see that, if I talk about the, enterprise, CCI enterprise perspective. So in the CCI enterprise, you're going to learn about the GRE in more detail. You're going to learn about the IP and IP. So IP and IP is again IEEE standard one. So GRE is a Cisco one. And then you're going to learn about the IPsec, right? Then you're going to learn about the anything else, MPLS based VPN. Somewhere you can see the MPLS, right? Then you will learn about the multi-point VPN, DM VPN comes in the picture. Then you're going to learn about the again IPsec. Then here you have IPsec, GRE IP. So these are the comes in the L3 VPN. You're going to learn about the in the CCI enterprise, right? But if I talk about the service provider, I'm going to use the red color. So in the service provider, you're going to talk about the L2 VPN, GVNS, VPWS, VPLS, Atom, LA2 VPN, this one, right? L2 TV version 3, QNQ tunneling, IPLS. Right? Sometimes I teach the QNQ tunneling in the CCI enterprise as well, depend on the situation, right? and then nothing, and then this part. So in a service part, I'm not gonna teaching the IPsec because it's not a part of the service part. Service part means what? Service-based VPN, not the customer-based VPN. In an enterprise means what? Customer side. Service part means the service side. But if I talk about the CSI security perspective, in a CSI security, you're gonna learn about the more detail of the SSL VPN, remote access VPN, this thing. In the CSI security, more about this thing, IPsec. So it's a combination of all the tracks, man. The VPN is not a small, it's a huge, right? So VPN means what? VPN has a multiple, like, people has defined multiple names of that. GR is a clear text VPN, GR is a point-to-point VPN. It's also side-to-side VPN, right? But eventually we are getting the one side to the another side. But it's a clear text VPN. We are not providing the security to the data. We just providing the connectivity, that's all. If
Okay,
you
so
want
basically the idea is private tunneling or
communication,
connectivity,
private
and it may
network
or may
extension.
not be encrypted.
Yeah, to just extend the private network, that's all. Right? So if you want to provide security, right, then you need to implement IPsec. IPsec is a suite of protocol. Suite of protocol means what? Understand, it's a very confusing word, suite. So it's a one box. So understand, this is called as a suite, right? So in under this box, we have multiple types of protocol. So we have ESP protocol, you have AH protocol, you have ISACAM protocol, you have Oakley protocol, right? You have a like what we call encryption protocol, you have a hashing protocol, you have a authentication protocol, multiple types of protocol under the IPsec. Multiple types. IPsec is like an ocean, man. Even I was reading the one of the book in the IPsec in the 2018, and I found the writer wrote this statement on the book, right? You cannot become expert in the IPsec. It's a big ocean. I remember like in the last my CCI enterprise batch in 2020, there was a multiple people from the Cisco and the Accenture, right? So I taught them the IPsec. So it was a 30 hours of the session only for the IPsec, only for the IPsec, 20 hours for the DMEP only. So if you want to implement the security, then you need to go with the IPsec protocol. How you can do that? So what IPsec is basically going to do that, I'll tell you. So basically, in this case, what happened? I'm going to implement the IPsec protocol. So my data is not secure, right? So basically, if I'm going to understand the concept, if I'm going to send for example, this PC is going to send the traffic to this PC, right? So what they will do is, for example, he will say, hey, hello. So if this message, it comes to router one will send this message to the ISP. So on the ISP side, what happened? There is a bad user, right? That's always have a perspective to intercept the data or eavesdrop the data. And after the eavesdropping, right, they can treat you. Hey, I need some money. Otherwise, I will leak your data. Maybe you're sending your, like, you're making a video calls, or maybe you're sending the photos, right? They can do anything with your photos, right? Because you are just sending the photos on the ISP side. They can, main purpose of the attacker, what is the main purpose of the attacker? They are just going to threat you. After the threatening, they can ask for the money ransom, right? They can ransom your money, right? I need some money, otherwise I can leak your photos, or maybe I can leak your documents, right? I can leak your conversation. That's a mean. So attacker mean perspective is what? They are just trying to attack your data. So right now, that's a WhatsApp. Right now, you guys are using the WhatsApp, right? So when you're gonna use the WhatsApp video call on the, or maybe you're sending some data, there you will see that message over there. Okay, this complete call is an encrypted call. It means it's a secure call. If it is not gonna happen, take example, if the WhatsApp is not gonna provide the security, then what happened? Your data will be leaked. Understood? because many things you are setting on the data, right? Many things you are setting on the WhatsApp. You are sharing the pen card, sorry, not pen, like a credit card, debit card, bank account, password, even the OTPs. Understand if this is not secure, then what happened? Attacker can attack your data, right? So what I can do with that, I will say that, hey, listen, whatever the data I'm gonna send the hello, I will convert this hello, right? HE double LO into the different format. I will say that I'll say the one. So if H is there, I will say the one. If E is there, I will say the pound sign. If L is there, I will say that there will be exclamation mark. And if O is there, I will say that there's a two. So instead of sending the hello, what I can do that now on the data one side, on the data one, I will perform the encryption over there. So if I'm going to do the encryption now, what data I'm going to send it? Instead of sending the hello, I will say the one pound sign. Then I'll say the exclamation mark, then I'll say the two over there. So now understand this concept. Does on the link banking or use the IP? Of course, everywhere you use the IPsec. Even you are making your transaction right now, right? You're using the IPsec. Either you're going to use the IPsec protocol, either you're going to use the SSL protocol, depend on the requirement. What they are using it, you will understand more depth when you go in the security part, CSI security part, the SSL concept in the IPsec. Which kind of VPN you're going to use it. But yeah, IPsec and SSL both are same thing. Simple language I can call you. IPsec VPN is a side-to-side VPN that has to be connected with the routers. SSL is a remote kind of VPN. Like, for example, you are sitting on the beach and from your laptop, you just connected the VPN to your company network and you're accessing your data. That's a SSL VPN. Whatever the website when purchased now, everywhere the security is there, man. Either the SSL and the IPsec. Either you will find the SSL or the IPsec. So SSL is mostly there because of the remote access VPN. IPsec you will mostly find in the corporate network. Don't worry, we'll see this more detail. I cannot conclude everything in the CCNP man. Understandable, because it will take the 20 hours of session only on the IPsec protocol. Then the 15 hours of session on the like a DMAPN and GRE. Everything is there. Hold on. Okay. So what they will do that encryption, they will convert this data into they will convert the clear text data into the unreadable format. Unreadable format means what? You cannot read it. That's the meaning of encryption. The meaning of encryption means what? Understand? The meaning of encryption means what? The meaning of encryption means let me write down over here. The meaning of encryption is what? Convert your data into unreadable format. That's the meaning of encryption. So if you see that, I'm doing that same thing, right? The text information I'm converting the untext information, unreadable format. So when this bad user is trying to intercept the data, hey, what is data is going on? Let me see, check it. They can say, oh, what's up? Well, this is one and pounds and exclamation mark two. I don't know what's the data is right now. They will just ignore it. Right? Because they cannot understand this one. When the receiving end, right, they will receive this data, what they can do that? They will apply the same logic. They will apply the same logic. The logic is what? The key that I'm using right now. Encryption comes with the key to decrypt that. Yeah, I'm coming to the point. So the key that you can see that I'm using what is the key over there? The key is what? If there is a data is H, I need to use the one. If the data is E over there, I need to use the pound sign. If the data is L over there, I need to use the exclamation mark. If the data is O over there, I need to use the two over there. So this is the key that I'm using right now for the encrypt. So same key must be there. So what the key must be present on the router 2 side as well. How does this key will be exchanged? I'll come to the point. Hold on. So this is the key that I have. So if H will be there, I'll say the one. If the E will be there, say the pound sign. If L will be there, I'll say the experience mark. If the two will be there, I say the O over there. So whenever this data comes to the router number 2, what router 2 will do that? Router 2 says, hey, let me do one, let me decrypt the data. Because encryption, I cannot read the encryption data. I need to decrypt it into the normal format. Decryption is what? Convert your unreadable format data into readable format. That's the meaning of decryption. So one side you can do the encryption, another side you can do the decryption. Same way, when this guy will send the traffic, this guy will do the encryption, and this guy will do the decryption. So it's opposite as well. Now, so when the router 2 will receive this packet, what router 2 will say? Okay, there's a value is 1. 1 means what? I need to convert into the H by looking this key over there. Okay, there's a pound sign. I need to convert into the E over there. Okay, there's an exclamation mark. I need to convert in the L over there. You can see that. Another exclamation mark. I need to convert the L over there. And there's a 2 over there. I just need to convert the O. So now finally you can see that this key was there on the router number 1 side. This key was there on the router number 2 side. So when the router 1 has sent the hello packet, sorry, hello message, router 2 exactly received the hello message. The bad user has no idea. Okay, by any chance, if the bad user know about the key, they can then decrypt the data. If by chance. Right. So to avoid this problem, what we are doing that to more provide the more integrity. So take example, if the bad user has an idea about the what we call this data, sorry, this key. So if take example, if the bad user know about the H is gonna use the 1 and is gonna use the pound sign and the L is gonna use the exclamation mark and O is gonna 2, they can do anything, man. Understand the concept. The bad user know about this key, what they can do that now. They will receive this data and they will change to the hello to the what? Hey, listen, please transfer money, $20,000, right, into account 123. So they will convert this hello message into this message and they will resend to the router number 2. So when the user will receive it, what the user is thinking that, okay, I think so the user 1 is requesting for the transfer the money into the 123, but this message is delivered by whom? The attacker. So if they know about the key, they can do anything. They can change the message. They can deal with your integrity. Now you have lose the integrity. To maintain the integrity, what we are doing that, to maintain the integrity. So on this particular data, right, once our data is there, so on this particular data, what happened? I'm gonna add some hashing value. So I will add some extra hashing value. Maybe the hashing value will be 2345. This is my hashing value. So this 2345, this is my data. And then after that, I'm gonna use the hash value over there. So this hash value prevent the integrity to lose. So if the attacker will try to understand, if the attacker, when the ISP will receive this packet, if the attacker is trying to decrypt the data and is trying to change the data, what happened? They can just change the data, but they cannot change the hashing value. Hashing will be still the 2345. So when the router 2 will receive this data and the hashing, what they will do that they will perform, the router 2 will perform the hashing on this data. So if the router 2 is going to perform the hashing on this particular data, what they will find it? They will find some different value, maybe the 4569. So what happened now? The router 2 is going to verify, okay, is it matching? No, it's not matching. If it is not going to match, what router 2 or the receiving end to do that? They said, hey, looks like someone has modified the data in between. This packet is not a good packet. I need to drop this one. So we also need to maintain the integrity. So first we need to maintain the encryption. Second, we need to maintain the integrity. To maintain the integrity, right? Integrity. To get the integrity, we need to perform the integrity. We need to do hashing. And to do the hashing, we have some protocol. I'll come to the protocol. Don't worry about that. So once we have done with the encryption decryption, then we need to come to the integrity, right? And to exchange the key, right? We have a algorithm that's called the Diffie-Hellman algorithm. So the key that you can see that, right? The key that I have. So this key is basically exchange, right? By the one algorithm. So there's a one guy over there. So what this guy will do that, right? So there's another guy over there. So this guy Diffie-Hellman, DH key. So this guy is gonna exchange this key from one side to the another side. It's a dynamic way to exchange the key, and this key will be keep changing. It's not the same always. If it will be same, then what happened? If the attacker will get to know that the one key, they will always do the attack. So this key will be changing by the some random time. And then finally, what happened? Once the key will be done, once the encryption has done, once the integrity has done, then I need to provide the authentication. I need to make sure that I'm forming the VPN between this side to this side is the correct VPN. That forming the VPN from router 1 to router 2, this will be the correct one. So we need to make sure that I'm forming the VPN with you and you are forming the VPN with me. And to do this thing, we need to put the password over there. And the password is known as a pre-share password. Pre-share means what? I have already shared. Pre-share means what? I have already shared the password through the mail, through the WhatsApp, through the call, or any way. So now you can see that what information I have till now. We have an encryption. We have a hashing. We have a Diffie-Hellman key. We have authentication. To share all this information, router 1 is going to share this all information with the router number 2. I cannot share the like encryption first, hashing first, Diffie-Hellman first, and authentication first. I need to encapsulate, I need to convert this all information into the one box, and then I will share. So I need a one protocol to share this information. That protocol comes in the ISACAM. ISACAM stands for Internet Security Association Key Management Protocol. Management protocol. So this is the one of the protocol that works on the UDP port number 500, right? So this protocol is going to help you to exchange this information with the router number 2. And router number 2 also will have the same information, right? And router 2 is going to share the same information with the router 1 with the help of same protocol ISACAM. Once the protocol...
Sir, what's this? Okay, I'll let you speak first.
Once
Okay,
the
sorry.
protocol, once the information will be exchanged, then what happened? They will create a one tunnel, and this tunnel is known as a phase 1 tunnel. In the phase 1 tunnel, basically we are exchanging the 6 packets over there. So what protocols I'm going to use for the encryption? What protocol I'm going to use for the hashing? Right? So if you see what I can do that. So I'll remove the GRE right now. Okay, so simply remove the GRE. Interface loopback number 1. Sorry, my bad. No interface tunnel number 1. That's I'm going to remove the GRE right now. And R3 as well. It was 2. I'm going to remove the static router as well, right? That's I give the default out. Something on the router 1 as well. Right? Now what I can do that. So if you see between the router 1 and router 3, we don't have any connectivity. I'm just going to run the EIGRP right now. normal routing protocol between all the network. So I'm gonna advertise all my network, this network, everything on router 2 as well. And router 3. So we don't have a GRE right now. So we are creating the IPsec VPN, right? So in IPsec VPN, we don't have a concept of the tunnel interface. We do have when you go in the higher level, we do have, but normally right now we are doing the policy-based VPN. So GRE is called as a route-based VPN. Why is a route-based VPN? Because we are extending the route through the routing protocol. To run the routing protocol, we are going to use, we are running the routing protocol on the GRE side. What is the different deferred element? What is the deferred element? I didn't understand the question, deferred element. So if you see the policy-based VPN, what I can do that on the router 1, or you can also call it a side-to-side VPN as well, right? You can also call it a point-to-point VPN as well, and you can call it an IPsec side-to-side VPN. So multiple name has, don't confuse with the name, right? This guy also called it a IPsec VPN. This guy also called it a, what do we call? IPsec point-to-point VPN. Multiple name they have given. But only the thing is that only the difference between the GRE, if you see the GRE is also a point-to-point, and IPsec is also point-to-point, right? If you see the GRE is also a point-to-point VPN, and IPsec is also point-to-point VPN. The major part is what? IPsec provide the security, right? It doesn't provide the security. That's a major difference is that. So you can see that what I can do that, I'm gonna use the protocol. So the first command that I'm gonna use is the crypto on the router number 1. ISACAM policy 10. So I'm gonna use the ISACAM protocol. That's gonna encapsulate my all encryption algorithm, hashing algorithm, diff element, even the authentication part. So with the help of this protocol, I'm gonna encapsulate my all information. So encryption, I'm gonna use, I have a multiple ways. So let me show you in the CLI here. Crypto ISACAM policy. I'm gonna use the policy 10 over there. Multiple policy you can create for the multiple site. So right now I just have a 2 site. If you have a multiple site, then you can create the policy number 10, 20, 30, 40, whatever you have. Encryption, I can use the 3-DES is a less secure. It's a more DES is a less secure. 3-DES is a more secure, and AES is a more advanced secure. Which one you're gonna use it? It's totally depend on the requirement. ACE is an amazing one, advanced encryption standard. It doesn't mean that we are not using the DES, because if you're going to use the S, it will take the more time to encrypt the data and decrypt the data. So the delay comes in the picture. If you see the phone pay, right, whenever you're making a transaction through the UPI, you will see the AES over there most of the time. If you just have a look over there, you will see the AES 256-bit or maybe the 5112. So depend on the, so it's totally depend on the requirement by requirement. But the more critical data you have, that's going to use the ACE. Then I'm going to use the, so I can use the ACE right now. For the hashing, I'm going to use the MD5, or you can use the SHA. So I'll just go the lesser one. MD5 is the less one. It's take the load time. Size a more secure way. Then Diffie-Hellman algorithm, I can group. I'm going to use that. That's a Diffie-Hellman algorithm. I can use the group number 1. You can use the group number 2 and group number 5 as well. Group number 1 is a lower number, and that's give you the lower range of the key. The group number 5 will give the higher range of the key. So that's the group number 1. So what I used till now, so I said the encryption will be AES, hashing will be MD5, and group will be 1. make sure that the policy that you're creating on the router number 1, it has to be same on the router 3 as well. If the same will be not there, they won't form the VPN. Then I'm going to use the authentication pre-share. Right? Then last is what? I'm going to use the crypto key. The key I'm going to use the Cisco 123. Address will be what? Crypto key. I'm going to say the 2.2.2.2. So router 1 is forming the VPN relationship with the 2.2.2.2. Yep. And then same configuration I need to apply on the router 3 as well. Right? On router 3, only we need to change the address over there. So router 3 is going to form the neighborship with the router 1. After putting this command, what happened? You have a phase 1 tunnel, right? That's also known as a main mode. Right? In this phase 1, we are accessing the 6 packet over there. So by creating the phase 1 tunnel, it doesn't mean that we are securing the data. It is just helping you to create the phase 2 tunnel. That's known as a quick mode. So now the same thing, let me put the same configuration on R3 as well. All that. So now the R1, and now I need to create the what? Phase 2. Before creating the phase 2, what you have to do that, you need to make sure that what network has to be secure. Because IPsec, right, is going to provide the security. It will do the encryption and decryption. It will do the hashing. So I don't want to make sure that this network should be secure. I only want to do that whenever the traffic will go from the here to here. Understand, I'm making a policy. Understand what terminology, right, what I'm saying right now. I'm saying whenever the traffic is going from this site to this network, then the traffic will be secure. Because these are the users. So whatever the users are present in the 1.0 site, they are the management site. And whatever the users are present in the 2.0 site, they are the management site. So whenever the traffic is going from the 1.0 to the 2.0 and vice versa, the traffic will be secure. But whenever the traffic is going from the 1.10 or 1.0 to this guy, hey, this guy will go with the non-secure way. So whenever the policy comes in the picture, you need to create the ACL, right? So I say the access list, 100, commit, what IP, I say the all done on the router 1. So step number 2, I'm going to create the ACL to just match the policy. If you want, you can secure the data for secure the traffic for this network as well, bottom network 10 or 1.0 to the 10 or 1 or 2.0. But I don't want to do that. If you want, you can do that. But make sure that whenever you're gonna add the multiple network, if you're gonna provide the security for all the network, then router will take the more time to encrypt all the data. IPsec require the more memory and the more CPU on the router side. If you don't have a much memory and much CPU on the router side, then your IPsec will not form. All done. So same ACL I need to create on the router 3 as well. just oppose it. All that. Now what I can do that. I need to create the phase 2 now. So I say in a phase 2, I say the crypto IPsec transform set. Transform set means what? Now the meaning the transform set means what? It's gonna tell you, hey, you know one thing, now you are securing your data traffic. So for the data traffic securing, which protocol I'm gonna use? I'm gonna use the ESP. Transform set name is the ABC. ESP, this is for the encapsulation protocol. The ESP stands for encapsulation security payload. The encryption for this guy, I'm gonna use the AES for the phase 2. And same thing, ESP. For the integrity, I'm going to use the MD5. That's all. Exit. Same funda you need to apply on the R3 as well. So this is the phase 2 command. If you see that, why is it called as a phase 2 command? Because it's a transform set. Transform set means what? Now we are ready to exchange the data. Next is what? So how many things are now we have? Understand the concept right now? We have a multiple things. So we have done with the phase 1. We have done with the phase 2 tunnel, right? We have done with the phase 2 configuration as well. That's called as a quick mode. In the quick mode, we are going to extend the 3 packets. So total we have 6 and 3 is the 9 packets. After the 9 packets, right, the data will be secure. So I need to apply all those things. How many things we have now? If you see, we have a policy. We have a ACL. We have a crypto IPsec transform set. 3 things we have. I cannot apply these 3 things on the interface. So I need to group this thing into the one box. So we have a 3 box right now. You can see that I have a 3 box. Right? Now this one. I have a 3 box. Right? I need to group this box into the one box. And this box is known as a crypto map. Because individually, I cannot apply all this configuration into the single interface. I need to convert into the one box. So that's called as a crypto map comes in the picture. So in the crypto map, what I can do that. Let me apply this configuration on R3 as well. So apart from the ESP protocol, encapsulation security payload, we have another protocol known as AH, authentication header as well. Which protocol we are using the protocol? Again, it's totally dependent on the scenario. ESP is a more secure way. AH is a less secure. We do have a confidentiality in the ESP. We don't have a confidentiality in the authentication header. Now, the next thing is what we need to do the crypto map. Crypto map. Name the crypto map CCI. That's the sequence number 10, IPsec ISACAP. So I'm calling the phase 1. The phase 1 is the ISACAP, if you see that. Right? And I'm also calling the IPsec protocol, which is the phase 2. So under the crypto map, I'm calling both the things, phase 1 and phase 2, the main mode and quick mode. And now I'm saying that, hey, listen, match address will be what? The ACL number 100. If you see this guy saying, hey, the new crypto map that you have created, it will be disabled until you have defined the access list and the peer. Peer means what? To whom I'm forming the VPN. I see the set transform set. Let me define the transform set ABC that I have created on the router number 1. Right? And then I say the set peer will be what? So on the router number 1, I'm saying that, hey, I'm forming the tunnel between from this interface to this guy, 2.2.2.2. Make sure that you must have a digital. And all done, man. Same thing, I'm going to apply this thing on our R3 as well. Crypto map. CCI 10 IPsec. You can use any sequence number, that's fine. Right now, but again, higher level, you have to understand the sequence number is a very important roles. Match address. 100 set transform set. ABC set peer. It's a 10101. exit, copy and paste on R3 as well. Configuration has to be matched. And now I just need to apply it. How do I apply it? I just need to go on the interface, 0/0 crypto map CCI. Bingo. Either cam is on, same thing, crypto map CCI on R3 as well. So on the particular this interface, we are applying the crypto map. So if you see, I have binded all these three statement, 1, 2, 3 into the one crypto map. And then I applied the one crypto map on the interface side. Same thing on this guy as well. And now you can see that on router 1 as well. If I'm going to send the traffic now, ping, I see the 192.101 source, 2.1 source will be 2.1, 101. You can see that from router 1, I'm sending the traffic to the 2.1. Source will be 101. If you see the same ACL I have created on the router 1 as well, right? If it is going to match with the policy, then I have to have a VPN, man. Then my traffic will be secure. I already have a capture is enabled, right? And let's hit the packet. You can see that. So total we have X in the 9 packet, 1, 2, 3, 4, 5, 6 main mode. Phase 1 tunnel, 3 packets in the quick mode. And then remaining my ICMP packet, you can see that it's encapsulated by the ESP header. You see that? And now my all traffic, and remember that I've used the source IPs 101 distance and 2.2. Do you see the 101 and 2.2? 192.161.101 and 2.2? No, it's totally encrypted my data. You cannot see the data. That's a difference between the GRE and the IPsec. I don't see the data, man. It's already encrypted, everything. But if I'm going to send the traffic to the normal traffic, you see that if I'm going to send the traffic to the, simply, if I'm not going to use the source 1.1, I'm just going to send the packet to the 2.1. My traffic will be not secure. See, ICMP. Equal request is going on. You can see the traffic. But if I'm going to send the packet to the source 101, then it will match to the policy. If it is going to match to the policy, you will see the ESP over there. Even if I'm going to send the traffic to the 10.1 network, from 10.1 to the 10.2, man, this traffic will be not secure. Because I haven't called this guy in the policy. See, ICMP. So now you can see that on router 1. So Isaac can. Man was a man. The command. So one command was there. What could I forget? Yeah, so crypto. So crypto, Isaac Ham essay. So you can see that this is the phase 1 is up right now. Right? We have a router 1 to the router 3 connectivity. Distance is 2.2 and the source is 1.1. SM is security association. Security association is just going to represent the tunnel. And now you can see that so crypto IPsec Isaac essay. You will see that router 1. this interface crypto is enabled. That's a local address 101. Destination is 2.2.2.2. The port number 500, that's Isaac app. And you can see that I have sent the 9 packet, which is the encapsulated, which is the encrypted, and which is the digest means what? Hashing has performed. I have also received the, of course, if I'm going to send the ICMP request packet, I should receive the reply packet. So I am getting the decapsulation, doing the decryption, and doing the verification as well. That's against the digest value. So if I'm going to send the more packet, you will see the more values. Repeat 1000. So previously it was a 9, then I send the 5, and then I send the 1000. All this packet you can see in the encrypted. So if you see right now in the capture as well, all my traffic is ASP, everything. All these are secure, man. So I send the packet from the 192.168.101 to the 2.1. Do you see the 101 2.1? No. You see the public IP address only because inner header is totally secure. So now you can see that same behavior, the phase 2 information. So crypto IPsec say this amount of packet I have sent. So that's called as a IPsec side to so GRE does not allow you. It just provide the connectivity between the two sides. It's a point-to-point, side-to-side VPN. IPsec is also side-to-side VPN. Only the major difference is that IPsec is a secure way to do that. GR is not a secure way to do that. All good, man. Anybody has a question? I know you have very much question, but you can go ahead and ask me.
So in short, for the GRE, again, I must have missed a few things in between. But to summarize, let's say I have one site in Bangalore and another site in Pune, both connected through different carriers. So I can use GRE, keep my data on over their network.
But that does not provide the security. So that
No, of course, yes, but that's
that
my
allow you
private
to
tunnel.
exchange the private route.
Okay.
Private networks.
Okay. Got it. Thank you.
Anyone else? So if you want to just hide the private network, not a private, I can say, if you just want to hide the your internal network from your ISP, you can do the GRE. Simple language. So GRE is an amazing thing, man. I'm telling you, when you go with the higher level, you will see the multiple things with the GRE features. Like, take example, I'll give you just one scenario, multicasting, right? Multicasting, the customer is, so take example, one site in a Delhi, what happened, you have a multicast server. And in a Mumbai, you have a multicast user. Understand the concept. In a Delhi, you have a multicast server. In a Mumbai, you have a multicast user. Or maybe in a Delhi, you have a multicast server. And in the Nigeria, you have a multicast user. But in between, you have a multiple ISP. And take example, if the ISP does not support the multicast, then how are you going to route the packet? Because multicast is not supported by the ISP now. ISP, hey, you know one thing, my router does not support the multicast. How are you going to provide the communication between the Mumbai, Delhi to the Nigeria? You can use the GRE, man. GRE will help you. It's an encapsulation, man. It's an encapsulation mechanism. So they will carry your multicast traffic as well. Like if you guys remember that in OSPF, we read about the virtual link. Right? Alternative solution is what? GRE. You can do that. We can achieve the solution, same solution. Got it?
Yes, sir.
Nazir, you had a question. I'm so sorry, right? Go ahead. Nazir, are you there? Looks like it's not there. So that's all about the VPN, guys. Again, I just gave you the summary. It was not enough info because because only the VPN, right? If I'm going to teach you, the VPN will take the 40 hours of the session, right? So hold for the enterprise CCI lab, CCI exam, sorry, CCI training. You will see the multiple things in the VPN as well. We should not send a sensitive data from router 3. Why you not? Now we can send it because we have IPsec. You can send from the R3 as well. See, we were one. Sorry, 101 source will be. So Isaac Camp, so crypto. IPsec as spring. Each thing has a meaning, guys. Like a SPI is a very good concept. Like what is the SPI? It's a security parameter index, right? So each one has a own meaning. In like all the 6 packet, the 3 packet, 9 packets we are going to discuss, right? What is the AH and ASP? The difference is that what is the use of lifetime, right? How you can use the, because you can only apply the one crypto map on a one interface. So take example, if you have another site, how can I apply another crypto map with it? Then you need to use the sequence number concept. All good, right? That's for the VPN, guys. So I'll share the notepad to you. You just do the practice. It's very important. If you're not going to do the practice of the VPN, then you will not understand it. VPN requires the practice. So VPN is the overlay technology, right? Your underlay must be fine to get the overlay. If your underlay is not working fine, you will never get the overlay. So tomorrow we'll do that, what we call MPLS part, right? So be there. Then day after tomorrow we'll go the multicasting and QoS part. Okay, anybody has any questions? No, then we are good to drop.
Thank you, sir.
Most welcome. Bye-bye.
Have a good night.
Hey, good night.